So you're now into Unit 2. The focus of Unit 2 will be to talk about statistics. Here in the first sections, 5A and 5B, which obviously I've combined here together for you, we are talking about the basic fundamentals and the foundation of statistics. So you'll see this set of notes. There's a lot of reading that will go along with it. So obviously I don't need to sit here and read it all to you here again. So I'm going to, I think that you can get the majority of it for reading it on your own. Obviously you need to be, you're responsible for these vocabulary terms and the concepts that you see here in the notes. But like I said, I don't need to read them to you. So I'm going to hit the highlights of what I believe may need a little bit more explanation. So as I do that, I'm going to scoot on down to the first page and come down to qualitative and quantitative data. And qualitative is just that. It's categorical data. It's going to be distinguished by a characteristic, an attribute, or a category. So for example, if you were surveying people and you wanted to know what was the most predominant hair color in the US, for example, obviously people are going to respond with hair color, whether it be red, brunette, blonde, black, whatever their hair color may be, they'll be responding with that particular word. Versus quantitative data is just that. It's numerical data. It's so if you were interested in what's the average weight of American women, then women would be reporting what their weight is. The way that they would report that would be a numerical form. So a person's weight, a person's height, those would be quantitative data. So when I think quantitative data, I think about quantity, because quantity is a count, so numerical data. Qualitative data would be a descriptor. Okay. One of the examples that I gave you just below that is that Apple makes products. Obviously, they make iPhones, iPods, MacBooks, and so on. The types of products that they make is the qualitative data. But then if we were interested in more the business side and interested in how many iPhones, iPods, and so on Apple makes, then that number of those products would be quantitative data. Okay. Lastly, we'll conclude here on the first page with the two different types of statistical studies, descriptive versus inferential statistics. With our descriptive statistics, you're going to be mostly involved with collecting and organizing the data, and then they would pass it along to statisticians who are more interested in drawing some conclusions, trying to make some predictions about the data that was presented to them. Hey, here are some patterns that we're seeing, and this is now what we can say then about the overall population. So we'll flip it on over to the next page. At the top of the page, you see two vocabulary terms, population and sample. Population is just obviously, depending on what you're surveying, it's the entire group of people or the entire number of objects, the entire number of states, whatever your focus may be, but you would not exclude anyone. The population would be everyone would be counted. Sample would be just a subset of that population, and only part is going to be observed or surveyed. Obviously, there will be times that statisticians are not going to be able to always rely on the full population. The full population would give us the best results, but there are many reasons why we can't always rely on the full population. Sometimes have to get to just a sample. And I outlined that in the notes for you, but common reasons would be the expense and time involved with doing the full population. A lot of statistical studies are grant funded, and so with grant funding means then that there's a specific amount of money, and generally a lot of times a specific amount of time. And so in order to reach the entire population, that may be near impossible in the amount of time and money that you're given, so you would have to scale it back down to a sample. And we'll talk here in a few minutes about, how do we pick the right type of sample so that we are accurately representing the population. All right, so I'll move on down to example 1. I'll do example 1 with you and then let you try example 2 and 3 on your own. In example 1, it says that a survey firm is interested in the number of deployments of active duty Marines. So the surveyor asked 250 Marines from Camp Lejeune and 250 from Camp Pendleton. How often have you been deployed overseas for at least 3 months? And since you joined the armed forces. Sometimes what I find with these problems, whenever they ask you then, okay, to identify what's the population and what's the sample, I like to pick out the sample first, because the problem is going to tell you what the sample was. They're going to outright tell you who was chosen as your sample. And you can see here in this problem that those 250 Marines from Camp Lejeune, I'm just going to abbreviate, and the 250 Marines from Camp Pendleton. That's my sample. And then I ask myself, who do these essentially 500 Marines, who are these 500 Marines then representing? And they're representing all active duty Marines. So, you can do this any way that you like, but that's just something that I've found to be helpful for myself is that, like I said, it's going to come right out and tell you in the problem what your sample is, and then ask yourself, okay, these then represent a larger population. Who are they representing? And those 500 then are representing all Marines. As we move on down the page, like I said, I'll let you do example 2 and 3 together, or on your own by looking at the solution key. We'll move on down to your next vocabulary term, which is bias. And a bias just occurs when there is a difference between the results that you get in your sample versus the actual truth about the whole population. And there are two types of biases, and I put those examples below here. There is the first one is intentional bias, and then the example below is unintentional bias. So intentional means that, hey, you wanted to prove one way or another for your own gain. So the example that I put here was that a cigarette company wants to prove that smoking doesn't affect a person's level of physical fitness. So the researchers then go to an advanced aerobics class, and whenever they're in that advanced aerobics class, the only people that they ask are those that smoke about their level of health and physical activity. Same team then goes to a low impact class and asks only those that don't smoke about their health and physical activity. So essentially then they're trying to say, oh, well, those that don't smoke are having to do low impact classes, and those that do smoke are able to participate in the advanced classes. And obviously, that's not always the case. There's limitations all around, okay? An example of unintentional bias. A group is interested in measuring the number of teens using illegal drugs, and they want to just survey high school students around the country. Just by sounding like that, just by, looking at that, you may say, okay, well, if I'm surveying high school students and I want to know, if teens are using illegal drugs, then that's a good place to get my data. However, if you think about it a little further, at least two demographics are going to be eliminated from that particular study, because there are students who are homeschooled and those that have already dropped out. So, those they shouldn't be neglected because they are part of the population. So we need to find a way to also include some of those other types of students so that you get a good representation of the full teen population. So basically, a couple of points to remember whenever you're thinking about bias, making sure you don't want a particular part of the population to be over or underrepresented, or a particular portion of the population to be over or underrepresented. You want to try to keep it as balanced as possible. And if you do end up getting some biases that making the sample statistic higher or lower than the actual truth about the population. We'll flip it on over to the next page. At the top of the next page, we are looking at obviously your ultimate goal is to have a sample that is unbiased, or as unbiased as possible. And an unbiased sample of the entire population would not have any preference to income, education, gender, race, religion, political affiliation, your age, so on. The list goes on. There's common sampling techniques. I encourage you to maybe perhaps also watch the video link that I have here. It's just a short YouTube video, but it kind of reiterates some of the techniques that I'm about to talk about. These are just the main methods, the next 5 or 6 that I'm going to go through here. And then sometimes you might find some statistical studies where you might see, hey, they used a combination of a couple of these. And the only one that is a bad sampling method, which we'll get to in just a moment, would be that convenience sample. So what I'm going to try to do is go through each sampling technique and just give you an example of each. So with the random sample, every possible item has an equal likelihood of being selected. So for example, you think about it, if you go to a, I want to say a fair, but no, go to a So let's say we go to a conference and they're raffling off something at the conference, and as long as everybody is, and they tell you put your name in the hat. Well, as long as everybody has a piece of paper where they have the same size, same shape, or everybody has the same size ticket, and you put that name, everybody is then has an equally likelihood chance of being drawn from the hat if everybody's ticket or name on the piece of paper was the same size, same shape. So a systematic sample is surveying where you draw every nth person or nth item off a production line. So an example that I would give you here would be to say, let's say we're interested in figuring out how students feel about the food in the cafeteria. And we decide, okay, well, we're going to stand at various points along campus and we're going to survey every 10th person that comes by. Okay, and so okay, when the 10th person comes by, you say, hey, please, excuse me, can I ask you some questions? And then you let 9 more people go by, and then okay, there's the next 10th person. So every 10th person that would walk through, you might ask. It doesn't have to be 10. That's why they use the in there, that it could be every 6th person, 100th person, 20th person, 25th person. It could, any number that you want to. Those are usually easy to identify because there's going to have some number associated with it. Cluster sample is when a population is divided into regional or geographical areas. Then we select groups at random, and either everybody in the group is chosen or a random selection from each of those groups is sampled. So the example that I'll give you here is, let's say we divide North Carolina into 3 regions, the coastal region, Piedmont, and mountainous region, and we survey small businesses and ask how they're faring in this particular economy. And what would end up happening, instead of letting North Carolina be represented by only people in the mountainous regions or only people on the coast, we would then go through and we would select a portion from the mountains, the Piedmont, and the East Coast, so that then we have each region of North Carolina represented, and then we get a better indication of how small businesses are faring in this particular economy. So stratified is your next one, and that's whenever your population is divided among characteristics that they share. You can, maybe be looking at age groups, gender, college major, and then essentially then you take a random sample from each of those characteristics. So let's say, for example, we grouped our high school students together by class. So we've got our freshmen, sophomore, juniors, and seniors, and then we asked them about their post-graduation plans. Obviously, seniors, it being more pertinent to them, they're going to have a much clearer, likely to have a much clearer indication of what they want to do after graduation, as opposed to a freshman who is just getting into high school and they may not know what they want to do. It will likely change several times over the course of the next several years. So that's why it would be good then to group according to your class at school. And then be able to say, okay, well, this is what the majority of freshmen think they're going to do after graduation. This is what the majority of seniors think they're going to do after graduation. Lastly is a convenience sample, and that's polling at a certain time in a certain place. These are generally very biased, and you definitely want to try to avoid a convenience sample if at all possible, because usually you will have some over or under representation involved with a convenience sample. The example that I will give you here is that, I'll go back to the example where we were asking students how they like the cafeteria food. Well, we could still do that here with this convenience sample, but here's the difference with the convenience sample. I'm going to stand in the library and I'm going to ask the first 10 students, how they like the cafeteria food. And I'm going to get 10 responses, and then I'm going to let those 10 responses dictate what the entire feelings of the entire college. And 10 is definitely not enough. And likewise, just standing outside of one place at one particular time is not also either a good representation of the entire college population. So what I encourage you to do now, pause the video, um, maybe look at that YouTube video. It will reinforce a lot of what I just said. And then go through and read these 5 scenarios and see if you can determine which sampling technique is being used. And then check yourself with the solution key. I've been talking about, we want to try to get away from our bias. There is also what's known as error, and error is whenever there's a difference between the results obtained and the truth that we know about the population. There's some possible reasons for error. Sometimes it's just bad luck. You thought to your best efforts that you had represented the sample well, but unbeknownst to you, you may be over or underrepresented, unknowingly. Sometimes we might choose a sample that was too small, and like I mentioned before, there are some surveys that are set out from the get-go to have some bias already, intentional bias in them. All right, and we'll flip on over to the next page. And I'm going to let you work through example 4 and 5. And I'm going to come on down to some other bias sources. I believe that by looking at the solution key that you'll be able to follow example 4 and 5 no problem. Some other bias sources are voluntary response polls and call-in polls. If you think about it, with both of these, you get to choose yourself. And with the voluntary response polls, many of them being with magazines and internet, that's going to exclude people that don't subscribe to that particular magazine, or it's going to exclude houses or people that don't have access to internet. Likewise with call-in polls, strong opinions are likely to prevail, because you think about it, a lot of times, if you have a really strong emotion about something, you probably are more likely to comment on it than if you're, kind of indifferent. It could go either way. You may not wish to express your opinion about it. Let's see. We'll move on then down to the bottom of this page where we talk about our margin of error. And I'm sure, with this being the political season, and you see a lot of polls now, a lot of times they'll offer a margin of error. You'll either see it on the screen, and every once in a while they'll say it, but usually it's just verbally on the screen whenever they flash up a particular statistic at you. What we want to talk about is how do you compute, given that margin of error, how do you compute the confidence interval for that, and then ultimately what does that mean? So in example 7, it says 61% of U.S. citizens have a valid passport, and the margin of error for that survey was plus or minus 3%. So we first need to figure out our range here, and you find that very easily by taking the statistic that you're given, and you add and subtract your margin of error. So I'm going to say 61 minus 3 and 61 plus 3. Obviously 61 minus 3 is going to give me 58, and 61 plus 3 is going to give me 64. So then what this means then is that, and these are percentages, we are confident that between 58 and 64% of U.S. citizens have a valid passport. Okay, so that's what that means. So whenever you see those political polls of plus or minus 1% in favor of one of your candidates, then it's, we can say, well, we're confident that between, and you just take that statistic and add, subtract 1%, that person would win the election, for example. All right. And then lastly, as far as on the last page, we want, in order to avoid as much bias as possible, we want to be purposeful when we collect our data. Try to do your research ahead of time. Make sure that you know as much as you can about your population so that you can avoid as much bias as possible. Types of things that I'm going to hold you accountable for from this section. If I gave you a scenario, be able to define the population of the sample, like I showed you in example 1. And then if I gave you a scenario, be able to tell me whether it was biased or not. And then lastly, you'll need to know those sampling methods. Not that you're going to have to give me a definition on them, but you'll need to be able to read a scenario and determine which sampling method was used. Okay, so like it was in the middle of your notes there with the numbers 1 through 5. So be sure that you can do those. All right, that concludes this section.